Hi everyone, this is Mrs. Dr. B. We are going to be doing mass to moles or moles to mass problems in stoichiometry. In this type of problem you only need two of the three definitions, so you will be using only one of your two molar masses, either the molar mass of the known or the unknown, but in all cases we will be using the molar ratio for the problem. And again, this all depends on what how the problem reads. So let's look at this first problem that I have. And you can see that it says how many grams of CO2, there is our unknown, are produced when I start out with 2.3 moles of oxygen gas. So what we're wanting to do here is we're wanting to say, okay, so where are we starting? Well, we are starting with moles of the known, which basically means we do not need, based on this, the molar mass of the known. What we are going to need, however, since we are looking for grams of the unknown, is we're going to need the molar mass of the unknown, right? So let's go ahead and figure this out. The molar mass of the unknown, which is CO2, is going to be 44.01 grams per mole, per 1 mole. That's 1 carbon and 2 oxygen. And the molar ratio is not yet to be determined because guess what? We don't have a balanced chemical equation. So what we want to do is let's balance it really fast. It's easy to do. We can see that there is 1 carbon on both sides. There are 2 oxygens on the left. There are 3 on the right. We also know that there are 4 hydrogens. So if we put a 2 in front of the water, we now have 4 oxygens on the left. We have 2 on the right. We just put a 2 in front of the oxygen. We now have our balanced chemical equation. Now that we have this, we can go ahead and we can get a molar ratio. The two things are in our problem are oxygen and carbon dioxide. Remember, molar ratio is always going to be the moles of the unknown, which is CO2, and that is a 1, over the moles of the known, which is O2, and that is a 2. So we have our molar ratio, and we have our molar mass. We have the 2 pieces of information we need. All right, so let's go back to the roadmap really fast. We know from moles of the known to the moles of the unknown. We go through, and what I'm going to do is this. I had somebody else watch this, and they said this is the heart of the problem. Okay, the molar ratio is in the middle of every single problem, and without it you cannot do what you need to do. So consider molar ratio is right in the middle, and it's the heart of everything. All right, so let's go ahead and do the problem. Question mark, grams of CO2. That's how every one of our problems start. And so what are we going to do is we're going to take our molar ratio. Right, our molar ratio is right over here, and we are going to first of all set out our known. We have 2.34 moles of O2. Need to put that a little bit darker. Do that just a little bit darker. 2.34 moles of oxygen. And we are going to multiply by the molar ratio, which is going to be 1 mole of CO2 over 2 moles of oxygen. Moles of oxygen will cancel. And we will now notice that we have at least got the same who. We are now looking at carbon dioxide. Moles of carbon dioxide. We're looking for grams of carbon dioxide, which is why we need the other definition. When we look at this other definition, we know that there are 44.01 grams of CO2 for every 1 mole of CO2. Moles of CO2 cancel. And as I ask you to do with every single problem, I simply say check to make sure that what you are looking for, which is grams of CO2, matches the units, the last units in your problem. In this particular case, we can do the math, and we can say that 2.34 divided by 2 times 44.01, our answer is going to be 51 we had 3 sig figs. It's 4,9, so we would have 51.5 grams of CO2. There are 3 sig figs when we started. There'd be 3 sig figs when we end. All right, so there's problem number 1. All right, so problem number 2 is using the same exact setup, except this time we're asking how many moles of methane are needed to react completely with 54.3 grams of O2. So in this particular case, guys, what we are doing is we are starting with the mass and we are ending with the number of moles. So I can cover up the last portion of the equation, and we know this is what we're going to need to do. We're going to need, in this particular case, we have a different molar ratio, so let's do that. We need a different molar mass. We need the molar mass of methane. No, excuse me, we need the molar mass of oxygen. The molar mass of oxygen, since that's where we're starting, is 32 grams, 0.0 grams. It's 2 oxygens at 16 each. And that's what we're going to end up having as our molar mass. All right? All right, so we are going to end up with the number of moles. And what is the molar ratio this time? We are now looking at CH4, which is a 1. That is our unknown. So our molar number of moles of CH4 is 1 mole, because we're using the same molar ratio, and our known is oxygen, and again, oxygen is 2 moles of O2. All right, so we have our molar ratio and we have our molar mass. So all we're going to do this time is we are going to first do the mass times the reverse, or the dividing by the molar mass. So it's going to be 1 mole over 32.0 grams. So let's do this. We are asking how many moles of methane, CH4, equals 54.3 grams of oxygen. And we are going to multiply by, or divide by the molar mass, which is the same thing as multiplying by the inverse, O2. That then cancels. We are now going to do the molar ratio to go from O2 over to our unknown, which is CH4. And so we're going to have 1 mole of CH4 over 2 moles of O2. Moles of O2 cancel. And again, as I ask you to do, you can see we have moles of CH4, which is what we were looking for. All right, so let's do the math. We have 54.3 divided by 32 divided by 2, and we have 3 sig figs. And so our answer, it should have 3 sig figs. In this particular case is going to be 0.848 moles of CH4 is our answer. Okay? So we're only going to do a couple problems, so you've seen it work both directions. Again, what you're just going to do is you're going to take your stoichiometry roadmap and you're going to look at it and you're going to say, all right, so am I using all of the known side? I'm going from mass to moles and then over to moles, and I'm just going to cover that part. Or am I starting with moles of the known and going all the way to mass of the unknown? You can use these stoichiometry roadmaps as much as you want to, and or not use them at all. So anyway, there you go. Thanks, guys.